blast for the next, so if you don't blast for the next 2 days, we can't mine again. And as I said earlier, that's the dewatering. So you can see that we have the sump. So this sump is created within the mine for them to accumulate the amount of water within that level, so that that water won't fight against them. Because if you don't create a sump within the mine, it will affect. And you, the geomatic engineer, it's your duty to put down the sump where there's a waste zone, there's a waste zone. You put down the sump for them to excavate. That waste sump mostly go beneath the drain blast hose. And it is your duty to also report the amount of water level within the mine. So there are some areas there's always a pump available to pump water from the pit or the sump, or maybe there's a stagnant water, or maybe there's water affecting the company. We need to bring money. So if you can check the date, well, you see that this one is 1st January. So this one is 1st January, and the water level being at 46.5. So with this one, you calculate the remaining volume of water remaining to pump out of the pit. This is the remaining volume of water. And this one's to know the efficiency of the pump you are using. So we work with the mining department, we work with the dewatering team, we work with the service crew, we work with everyone earlier, and also present pickups. We do present pickups, as I said earlier, for the stability of the walls, setting out the design, the drain blast design. This one is an example. It's in survey monitoring point. Russell Pitts was West was. So this one was the geotech present, they mostly mounted on the walls. And we as a geomatic engineer do daily pickers on them for them to do the analysis. So if they can easily tell that, Charlie, this pit is moving, Charlie, these walls are moving, Charlie, these areas is moving. And mostly we don't take it for granted, because geomatic engineer data, we believe it is the true data for the mine. The Crescent too, I've talked about it, the ways down to pickups. We do weekly pickup, volume computation, and mine planning. So look at the first and second picture very well. You can see that we are mining, and we are mining for profit. We need to know that what we are mining, we are not mining waste, we are mining ore. So looking at the bottom floor, we mostly check that, are they mining at a correct elevation of floor? So we mostly check that if they are to mine at elevation of 23, how do I assess it that the whole floor is 23, but rather they are not mining maybe 25, so that it will left to 2 meters for them to get to the 23. So for you to achieve your total, or the whole all material, you need to do what we call the floor checks. So meaning if you check here, this is 249 floor. So from the 249 floor, the areas with the red means that areas are on high, and the areas with the blue mean that areas are low, and you have the yen, which is within this color, meaning that place is acceptable. So we mostly question the contractors and ask them that, why is that you have higher uh, red, or maybe lower higher blue, but if this one, the percentage of this one is good, we are okay to go, meaning you are within the range. Because you know that in mining environment, the terrain is undulating, it's not as smooth as you want. So we need to have an acceptable range for them to mine. So we mostly check the floors they are mining against. As a geomatic engineer, that's your job. So you check it and tell the company, the management, that, Charlie, how their mining is okay, how their mining is not good. This digger is not mining well. This digger is mining well. The floors are not good. Although we also, this one at the end of the day, we also check the drain blast people to make sure that they are doing the correct and right thing. So someone may ask, why underground? Why underground? Meaning surface to underground. Right now, we understand the surface concept. So why underground? From surface to subsurface. So why underground? They have a lot of factors and a lot of reasons, but I want to touch on these four. One, the economic consideration. So in the economic consideration, talks about the declining oil grade near the surface, meaning the high grade or the easily accessible oil near the surface have been depleted. You can't get access to any ore on the surface again. And also the increase in the stripping ratio. The ratio of waste rock to ore becomes economically unfavorable. You need to excavate a lot of waste before you can get access to the ore. So the moment you get to that area, you've been thinking about underground. Why should I take about 30 buckets of waste before I can get one bucket of ore? No, I need to have a second plan of that. And sometimes too, when the pit reaches a certain depth or a certain depth, when you are mining, every additional meter require removing plus 5 meters of waste for a minimum ore. When you reach a certain depth, meaning you need to mine a lot of waste before you can get access to some small ore, which is also not acceptable. And you have the geological factors. So under geology, they will also think about the ore body being it maybe deeply downwards. The ore body becomes narrow or maybe more discontinuous at certain depth. And also the multiple parallel veins or the disseminated ore body is better suited to underground method than surface. So with the environmental and the social pressure, also talk about the footprint reduction. So you know that the footprint reduction is going to talk about maybe your dust generation, your visual impact, your blasting. You see, in underground, all those things is being minimal. So you are not affecting the community much. So instead of I'm close to the community that much. So let me go underground so that all this external uh, impact or hazard will be reduced than being it on the surface. So at Asante Gold, we employ the two method, which is the sub-level cave and the sub-opening stoping method. So sub-level caving, basically, with practicality, is assuming you have a drive here and you have a stope here, and there's another drive at this section. So you either drill upwards. When you talk about drilling upwards, meaning you'll be on the lower elevation or the lower level, and you'll be drilling upwards to the upper elevation. Or you drill downwards, you'll be on the upper elevation and you'll be drilling to the lower elevation. So assuming you have drilled this section with the caving method. So with the caving, mostly the host rock need to be weak. So you see that, and you blast. So after just blasting with drilling within that 50 meters from down to open. So when they drill everything from top downwards to create the hole from top about 50 meters from top to the bottom, you the geomatic engineers will go and survey the whole point from the surface, from the upper elevation, and also come the bottom elevation and survey the bottom elevation. And at the end of the day, we'll give it to the mine planners for them to check for them to check the alignment of the drill holes. That is it okay, or there's no caps, or is it breakthrough, or there's no breakthrough within the drill holes. So after everything they charge, they blast the all body here need to cave on its own, meaning they need to break down on its own. They need to break down on its own. So they will be breaking down. You'll be there and you see that the whole of this place have come down. the whole of this place has come down to create a big void. And at the end of the day, you, the geomatic engineer, will go in with your instrument to scan the void, to quantify the amount of material being excavated from that void, or also the amount of filled material you will be needed to fill the whole place for them to use it as a drive again to work. And also the sub-level caving, the open stope consists of 50 meters sub-level with bottom-up stoping approach, whereby aims at level is backfill before the next upper level is mined. So anytime you excavate or create a hole, anytime you create a hole like this in between two levels, you need to make sure that you have backfilled the whole of this place before you can you have backfilled the whole of this place before you can also use that area to mine another section. So we use two methods. We use the sub-level stoping and we use the caving method. So the sub-level stoping is multi-level mining. You need to understand that. So after knowing the method we use in Chano for the underground purposely, as underground survey involves the application of all principles and techniques of survey beneath the earth. You see, in that side, we use mostly our instrument being accepted all over around is the total station. Why the total station? The total station don't use satellite to communicate. The total station can work on its own without any external assistance. So the only external assistance he will need will be his backside and foresight, or maybe the prism he's going to need to work. That's the resection by workstations. That's the only assistance he will need. But he don't need a satellite. He don't need any information from anyone. So he can work on its own. But you see, there's no network beneath the earth. So you can't use any instrument apart from the total station. So underground surveying is the specialized branch of mining survey concerned with accurate positioning and mapping for excavation beneath the earth surface, connecting underground workings with surface controls network, and ensure excavation which allow for design plan with a specified tolerance, monitoring ground movement, and ensure safety in 3 dimensions where GPS, GNSS signal are unavailable, as I said earlier. So let's look at
Engineer,
the primary
yeah,
objective.
engineering. Well, please, I just wanted to kindly remind you that we have approximately about 5 minutes more. Thank you.
Okay, welcome. Underground surveyors. So one is the guidance and direction, the volume and the progress monitoring, and the safety and stability. So the guidance and direction will be setting out the center line for drives, declines, and shafts, and also mainly excavation boundaries, whether the walls, the roof, and everything, and the volume and progressive monitoring for stope service for blasted volume and reconciliation development advancement measurement. So under safety and stability, monitoring the convergence, that's the roof, when the roof is sagging or hot, everything, and also the wall closures. So this picture just talks about linking from surface to underground, and you can easily see that with the photogrammetric image we have, with the D talk about access and also escape way, but the C also talk about the portal. So as a geomatic engineer, you need to provide how you will link from surface to underground on a photogrammetric image, give it to them, the one they can easily access or work within on the office to know where we can put certain things, whether be it our station, our drive, our everything. Move from surface. This is a pit. So the whole of this section is a pit we have mined, and we have connected this pit to an underground mine, meaning we have a portal here. all these carriers are reserved. They are good. We are going to mine. So what influenced this one being going underground from the cross-sectional view? You can easily see that the back at this section and come and mine the whole of this section out. But before you come in, before what can influence this cutback will be cost effective. Coming to the cutback because I'm a mine everything here. It's another open pit, which at the end of the day, that one is possible, but it's going to be cost effective and it's going to also affect the company that much because before you can get access here, you need to strip a lot of waste. So meaning the ore body was moving from this central direction. So we need to quickly target it underground. And this picture is just a picture showing us the reserve we have, how the underground operations goes and everything. So you, the geomatic engineer, need to first of all connect them from the surface, move everything controls, give them guidance, give them where the drive, give them where the direction is to underground. So we move from surface to the underground. So with the underground, you do CMS, the drone development, phase markups, and everything. Uh, so you can easily see that these are geomatic engineers underground. Here we were doing pickups of the area they have mined. After that, we will mark the place for them to also continue on. We will mark, sorry, a minute. Moderator, give me 2 minutes additional. So we will mark this section. We will mark this section as a geomatic engineer. So this is the center line, this is the right hand, this is the left hand, and they will continue with this one. So the jumbo operator will then come in to section these faces and drill the whole of this place, and we take another blast. So any blast we take underground is called a cut. So they will take another cut from this section we have marked for them as a geomatic engineer, then we continue with our drives. So whether being all drive, whether being anything. But this, you see, we have a cable boat at this section. We mostly do this one to support. So you can see a cable boat all along this side to support the walls or to support the loose material which want to fall on the personnel. But before they can drill some cable boat or support system underground for the geotech, geomatic engineer need to go in and spray that section for them because they will give the point to you, the geomatic engineer, but they don't know where it falls on the walls. So you go in and mark it for them that this is one. Charlie, this is two. My brother, this is another one. So they will go in and drill that section and put in the cable box. So they just do anything. So anything here you see is done by geomatic engineer before anyone can go in and work. So the left hand side of this one is called the design, and this one is called the asphalt. So you as a geomatic engineer, you need to always make sure that they are doing what? They are mining according to the design. So you can easily check the picture wall. You can see that, look at the shape of this one. You can easily see that the same shape is here. Look at where you have the shape of this one. You can easily see that the same shape is here. So we check everything to make sure that they are mining according to design. And at the end of the day, it's not going to cause loss to the company or it's not going to affect the company because the moment there's a deviation in a drive, meaning we are going to where we don't have much information to. So this is just a picture for you to know some areas at the end of the excavation. And this one was supposed to be a stop, but with that stop, you can't go in. This mesh was protecting that section. So I couldn't take a picture beneath it for you to know they will blast from this section to the bottom. So the space you have here, we mine multi-levels, meaning this area you see here, there's the same beneath you, there's the same at the top of you, but the distance is 50 meters above and below. So our instrument, we use total station for both surface and underground. We use total station, we use drone, we use the CMS, we use for SEPAC software, we use SEPAC, we use AutoCAD, we use Cloud Compare, we use Deswik, we use mapping for a lot of softwares. And this the total station I was talking about for the underground purposely. And this is the CMS. So with that, if you don't have a drone, you can use this CMS It enters into a stope and it scans the stope because no one can go into a stope. A stope is a created big void where that place is inaccessible. When you enter, there's no support system there, so anything can happen to you. And this one is the drone you mostly use. So let's do a visual comparison. So before geomatic integration from surface to underground, they were doing manual surveying, which took about 3 days per survey. And also underground monthly stope surveys with 5% volume error margin. So meaning they were getting some error, they were creating a big error margin for themselves, and data between the department was sometimes not being reliable that much. So rehabilitation planning takes more than 6 months like to for them because they need to go in and survey around the whole concession or the whole area before they can give the rehabilitation plan for them to maybe reclaim reclaim the area. But for now, in our modern geomatic system or way, drone surveys.
Please kindly mute your mics. Please kindly mute your mics. Thank you.
Drone surveys completed in 4 hours, processed in 2 hours. Then we are ready to go. And also underground CMS, as I showed earlier, scan completed in 30 minutes per stop. So within 30 minutes, we can scan more than 20, but at first they were finding it difficult. That has been the reason why all historical data, being it Obuasi or Bibiani, we don't have much stope information because way back then they wasn't having that instrument which was having them to keep void areas or stope areas or open space. Unified data set accessible to all departments. So right now, you know that the data set we have in all departments is unique. We are having we are on the same line. There's no argument between a rehabilitation plan. So in real time with quarterly update. So every day, as I'm talking to you today, we are even doing rehabilitation plan to update the whole site to know that yes, everything is on point. So lastly, I was supposed to show a reclamation area. So the whole of it, whether being in surface or underground, we can close the mine and backfill the whole place by the help of the geomatic engineer to tell them the amount of volume they will need to cover the whole place. If it is surface, we cover the whole pit. If it is underground, we backfill and close the whole mine so that you won't even know. But 10 years later, 20 years later, whether being the topsoil, you put back the topsoil and everything, you won't even know that that place has been mined. We have a lot of areas here. People are using them as their lay down. Lay down means they are set up their offices and everything. But before we came in, it was a pit where we were mining, where we were taking a lot of ore from that section. So thank you very much for your time.
Thank you so much, Engineer Wisdom. That was such a wonderful and then an inspirational presentation. We really do appreciate it. I know we have learned a lot from this presentation. We have learned a lot from this presentation, and we have a lot of questions to ask. I'll encourage you all to do well to jot your questions down, as well as start typing them in the comment section, and they will be addressed at the appropriate time. So at this time, we are going to take an address from our very own, our founder, Engineer Entry. He's going to do an honor by giving us an address, the founder's address. So please, Engineer Entry, please, if you are in the platform or if you're on the platform, kindly do us an honor by giving us the founder's address. Thank you.
Thank you very much. Can you hear me?
Yes, please.
Good. You are a very strict moderator, so thanks for that. But I'll appeal to you to give me a bit of more time than the 10 minutes, because as far as I'm concerned, this workshop is the most important. I've worked across mine sites around the world, and no mine has survived without geomatics engineers. So I want to feed you with some more information. So bear with me if I go over the 10 minutes. But first, I want to acknowledge the hard work of 2 students who really put this together with their colleagues with a certificate of appreciation, Watson Meredith Johnson and Abdul Momin Abdullah. The AusIMM, thank you for pulling it all together. By my last count, you were over 100 participants, even though the number of geomatics engineers in AusIMM are not that many. So well done. Secondly, I want to announce that we will be having the 11th annual conference around March. There is a planning committee working on that, and the theme will be Workforce of the Future, Building Capacity for a Changing Mining Industry. And in the panel will be the various general managers and mine managers coming across Ghana to update you on this important topic. So mark March, the actual date will come very soon. But I want to premise this discussion first on my personal experience working with my brother who was a geomatic engineer. Anytime he comes home from leave, he will do freelancing. And I used to carry the theodolite in those days to make some money, and secondly, to learn the concepts. I was then a secondary school student. So I learned basic things. I didn't quite understand the detailed calculations and so on. But fast forward, circumstances beyond my control put me into mining engineering as a student at Camborne School of Mines in England. And when I went there, I was told that there are 2 courses that if you don't pass, you don't get your degree, even if you have a first class. And one of them was surveying, which is a subset of geomatic engineering and GIS. And so the practical component was 3 months of survey work at the school's underground mine, surveying drives, crosscuts, and stopes, and coming up with reports. So if you don't do that and if you don't pass, then you don't get your degree. And so because I had some...
Please, if you just join, kindly mute your mics, please. Kindly mute your mics for us. Thank you.
Thank you. Because I had gathered some basic experience, it wasn't that of a problem. So we pushed through that program. But I kept asking the lecturer why, because I knew my brother was a geomatic engineer, and he told me that the mining industry used until I was sent on internship to Canada, one of the barrack mines. And in those days, when you go on internship, they pull one labor. He uses load factors to estimate his volumes. They get bonuses based on production. But anytime the surveyor calculated, it was far less. And so he said, you are an engineering student. You can do the surveying. So always cross-check for us. So then I'll go for the theodolite, do the survey. And so what was wrong were the loading factors that were being used, and it was fixed. So in battle, the British, half of the class went to work at the Channel Tunnel as surveyors. Even though they are not qualified surveyors by degree, they had learned enough to be able to survey these channel tunnels and so on. And so when I finished my bachelor's degree, came back to Obuasi, one of the challenges was that the chief officers were also complaining that their production was being truncated by the surveyors somehow, because the surveyors were jealous that they were getting bonuses. That was the analogy at the time. So I remember grouping a lot of some few chief officers, and I said, look, you went to the then KNUST School of Mines. That was what UMAT was called then, survey. So you should be able to get a theodolite and cross-check these volumes. And their response was, we did some basic work. I thought that was a lie. And I challenged them that maybe they didn't take their survey classes seriously. So if you are listening and survey or geomatics is being taught in class, take those practical components very, very seriously. Not just surveying, whether it's metallurgy at the lab, mining engineering, whatever, you need to take those practical courses very, very seriously. That's the first advice. But moving forward, I went to Colorado School of Mines in the US for my master's degree. I was a teaching assistant to the head of the department. Now, in those days, we didn't have a geomatics department at Colorado. So the lecturers teaching survey were all mining engineers. And I used to take students to the underground mine that belonged to the school to teach underground survey. And one student came to me and he said, how did you learn all these things, using all these equipment and all that? And at Cambon, we also have 3 months of practical work. So whether you like it or not, you have to do the survey work. And then from Colorado, I joined BHP in the United States as a mining engineer. Now I realized that the survey department was always stretched. Big pit, we didn't have enough surveyors. But I knew how to do the survey. So I went to the head of department and I said, I don't need a surveyor in my area. The drilling patterns, I can survey and stick the holes, the ramp designs, and so on and so forth. And I can see the relief on his face. He said, you have a theodolite allocated to you, do whatever you want. Little did I know that it was getting to the attention of management, the mining engineer who does his own survey. And so when the head of department, the survey department resigned, normally they will promote somebody within the survey department to be head, but they told me to go and act for 2 months while they are assessing internal and external candidates. So within the 2 months, I had attended 2 conferences on survey. And my thought process was, how do I minimize the work stress for these surveyors? And so one of the tasks, and I think the speaker said it, taking of holes for drill patterns, was taking a lot of their time. So in one of the conferences, somebody came to do a presentation on application of GPS to drilling. And so I implemented it at the mine, one of the BHP mines. We installed GPS on the drills, and we only upload the coordinates into the GPS. So the driller is able to then pinpoint the coordinates without a surveyor going in. And that eased a lot of the stress of the survey department. Secondly, because I'm a mining engineer heading the survey department, from 2 o'clock to 4 o'clock, I'll put all of them in one room and teach them mine planning. And I was surprised with the speed at which they picked up mine planning techniques, even more than a mining engineer from university being trained, because they are used to volumes and survey and so on. And so when a mining engineer goes on leave, I recommend to management that we move one of the surveyors to act as a mining engineer. Then my 2 months of acting passed, didn't hear anything, 3 months, 4 months. So I was getting worried that now they are turning me into a surveyor. So I went to the Human Resources Department and I said, what is happening with these interviews? Technically, I'm supposed to be part of the panel because I had to hand over, but nothing is happening. And then they told me, oh, a recommendation has come that we should be confirmed as a head of survey. So the first thing that came to my mind is, what is the salary? He said, it's more than double your mining engineer salary. Then I said, this is fantastic. All of a sudden, I'm going to bypass my colleagues and will be earning double what I was earning. And so 3 days' time after that conversation, the general manager called me into his office, excited. I knew he was going to give me my letter of offer and congratulate me for being the head of department. Little did I know that instructions had come from the head office of BHP in Australia to transfer me to Australia. So I was very sad, and that truncated my career in survey. But when I went to Australia, I realized they were doing the same old thing that the Americans were doing. Surveyors taking holes all over the place with their summer hats and all that, with their theodolites, surveying the coordinates for the drillers. Now, unfortunately, Mount Whaleback, which is one of the largest open pits in the world, had a lot of pits. And so the surveyors were stressed trying to cover the entire mine. So I went to the general manager and I said, this is what we've been doing in the US. GPS are on the drills. So you don't need surveyors to go out and stick the holes. He said, implement it. 1 week after installation of the GPS, the leadership of the union, the mine workers union, came to my office very angry. And they said, we give you 2 weeks to disinstall all those GPS, otherwise there will be a massive demonstration, a massive strike. What is their motivation? They thought we were just going to retrench surveyors. And I said, before you go on your illegal strike, can you go and talk to the surveyors? Because Newman, where the mine is located, is a very isolated place, temperatures of around 40 degrees. Nobody wants to go there. And therefore, we are always short of mining engineers. So all I was doing is to install the GPS and move mining engineers, some of the surveyors, into mine planning because of my experience with surveyors in the US. So they came back to apologize that they misunderstood the whole thing and so on. So that truncated my experience or my career in survey. But when I moved to the other side of policy for governments and investments for the investment community, we used to conduct what we call due diligence. If you're going to acquire a mine, you do due diligence on the mine, technical, commercial, legal. So we're in Spain trying to acquire a copper mine. We went underground and realized that it was a room and pillar type of mining, where the rocks were very, very fragile to technical issues and so on. And I saw this poor surveyor with his theodolite bent and trying to take the volumes. And I'm glad the speaker said it. And I said, why are you doing this? Why are you putting your surveyors under such risks when we have technology that can scan lasers and so on, then which can give you your volumes and so on? So that was my contribution at that stage. But I say all these things because technology is emerging, and the speaker mentioned some of them. In those days, we will have big concessions. In Canada, we have about 100 acres of concession, and I saw about 20 surveyors trying to survey to give us the topography before geological drilling can start. And so I asked the question, why can't we use drones? But in those days, drones were not very common, and it was quite expensive. But when we justified it, even though it was expensive, the speed and the accuracy was worth that investment and so on. And so what are some of the emerging trends? So for some of you doing geomatics or other courses, we are seeing AI and machine learning analyzing complex survey data for trends and efficiency improvements. We are seeing autonomous systems expanding the use of robots and drones for less human intervention. All these are research and development areas that are shaping the mining industry. So when you are talking about projects and all these things, you have to look at that. But don't do the theoretical part. I always challenge students, validate it in the field. Now, one of the comments that have come from your general managers is that students complain that they can't get data or validate information in the mines. And their response has been that you go through the wrong process. Typically, your supervisor should write to the mine, should write to the human resources department, not the students. The supervisor will mention the name of the students, the type of project work, the data required, it goes to the human resources department, then they forward it to the relevant department. But in many instances, you will see students trying to go directly to the mine, and it doesn't work like that. But I want to take the opportunity to talk about diversification or multi-skilling because I keep hammering that. You are in a very competitive world. It's not like our days. You are in a very competitive world where you need to multi-skill. I'll give you an example. I got a call from a colleague in Tanzania that he has acquired a quarry, but because he's so small, he cannot afford to hire a mining engineer, a geologist, and a surveyor. So he wants what we call 3-in-1. One person who can do the geology, the mine planning, and the survey. Please understand that there's a lot of expertise in Ghana. Help me. I combed throughout my network, called some of my colleagues. I couldn't find any single Ghanaian expert who could do mine planning, geology, and survey at the same time. The closest I came was a geologist who had done some mine planning in one of the mines and didn't have any survey experience. So we hired him. He had been home for about 3 years. So I called him and I said, you're going to Tanzania, you're going to be a quarry manager. But this is the condition. The condition is that you are going to hire a consulting surveyor to help you with the volume calculations, but you're supposed to take over from him in 6 months. Within 6 months, he used the basic knowledge, got the practical experience, and he now does mine planning, geological mapping, and survey. So that's the importance of diversification. To this extent, I'm glad that just recently, 3 of my mentees, one, some of you know, has gone from geology to be doing mining engineering in the US. He only arrived last week to do a master's degree in mining engineering. And when I asked him his rationale, it was very solid. I've been doing geology. I need to understand how mining fits into the geology. And then when geology is not doing very well, as most of us know, commodity prices are cyclical. And so when geology is not doing too well, he will go into mine planning. That's one. I have a mining engineer who consulted me on a master's degree, and I said, go and do a master's in business. She finished. I've been chatting with the speaker that we are going to develop their underground project in Bibiani for them. We are putting together the team. The team will arrive tomorrow. So we'll be working collaboratively. So I'm pulling that mining engineer into the project because she comes in with a lot of commercial skills. But the third one is a student who arrived in Australia just a few weeks ago. He did. I asked him what he's project management, coming to specialize in project management as part of the Master's in Business Administration. And what is it going to do? Give her project management skills. We have a guest. I'll give him about 5 minutes to talk about his experience as a geomatic engineering and how he transformed from geomatic to leading one of the very big project in Guinea and so on. So this is just to give you a bit of foundation on your thinking process going forward about job seeking, multitasking, multi-skilling, and so on. Thank you very much.
Thank you so much, Engineer Henry Entry.
Thank you very much.
We are so grateful. As we all know, I know we have a lot of questions to ask.
Madam Moderator, before we go to the questions, there is a guest online. Mr. Eddie, if you are there, we'll give you about 5 minutes to talk around the topic, please.
Okay, please, sure.
Well, very good evening to you all. And I'm glad to be part of this particular webinar. I'm so impressed with what our speaker has already shared. And Engineer Henry also has added a lot of facets to it. Because of time, I'm going to be very brief. Like Engineer Henry said, my name is Edward Amihie, a geomatic engineer. I graduated in 2009 from KNUST. And my career is one that I think similar to what Engineer Henry just outlined. I have risen from geomatic engineering, surveying, mine surveying to projects management. I have passed through mining engineering. I've done construction management, blast engineering at a point in time, and now doing consulting in Zam. So, like Engineer Henry said, and that is one thing I also hold dear, and I always tell young engineers is that don't call yourself in one box. Engineering is a convergence of disciplines, and you cannot be in an environment where you are working with different disciplines and you do not understand what the other person uses your information for. I had an experience in Liberia. The mine had existed, ArcelorMittal had existed for close to a year. And now there was a contention with the claims that the contractor has made over all these years. And it wasn't like they've mined and the material is there and you have to now go and just do an audit or something of that sort. They do pre-crushing, they transport some of the material. Some of the material had already reached India. Some has gone to China, wherever they are processing it. And now you are called in to verify all the claims that they have made. How do you go about it? So if the speaker did mention that surveying or geomatics in mining is the backbone of decision-making in the mine, that is very true. And you have to combine all your experiences, not only the technical skills you know in surveying, but including your appreciation of the mining processes to be able to come up with such a solution. And that was a very eye-opener for me, because from there, when I found myself in Congo and we moved from construction to production, I had to mine to mill reconciliation, which in most mines is a responsibility of the geologist. I was in charge of that. I did that for about 4 years, the mine to mill reconciliation for the mine. That is from the from the resource model to the grade control model to production to mill and to the gold production. And I have already said this a number of times to engineers that in those days, and even now, when you find yourself in an expatriate job, most of the time it is 2 years, and you're expected to, especially at a lower level, you are expected to transfer knowledge to the national so that you live there. I worked for almost 6 years to 7 years. I resigned on my own because I was so relevant. I went in there as a surveyor during the construction. I already had expertise in tailings dam construction. When the project was struggling, I offered to take over the construction of the tailings dam as the project lead on the development project. And I successfully delivered that. I went ahead to do the earthworks designs for the heap leach, and innovated and did a lot of things. And as a result of that, I wasn't only a surveyor. I had a survey team. I was training them. They were delivering on the services that they were supposed to deliver, but I was offering other services to the project department and things that, because it was a new mine and I had experience from different mines already, I had to bring that on board, and that made me very relevant. I had a bit of experience in planning. We had only one senior planning engineer at that time because the mine struggled to start production. So most of the recruitment had to be delayed. So I stepped in as a relieving mine planning engineer, and for about 2 years, they never saw the need to recruit another planning engineer because I was delivering my survey responsibilities, and at the same time, I was supporting mine planning. We started blasting. The mine planning engineer there did not even have experience in blasting design. I had already done that in Ghana. I had done that in Liberia. I stepped in there again, and I became the blast engineer until the 6th year, when almost 7 years before I left there, that we recruited somebody, we trained, we brought, we wanted to change suppliers as well. So we brought in the supplier to do a training, Orica to do the training. We recruited somebody, and that is when I was able to exit. So this is all to say that when we find ourselves in the mining environment, we should understand that right from exploration and prospecting to mine planning to development to construction or development to closure to post-closure, like the speaker has already said, throughout the value chain or on all the value chain, geomatics play important role. But it's not just geomatic. All the disciplines come into play. And the more versatile you are, if they are looking for only one person who can do both or can do a lot of things, that is where you fit in. I did my MBA quite early. I did my project management and I've been shuttling between almost all the disciplines of engineering. And I think that is something I'm happy Engineer Henry has highlighted on that, and he has given us some examples. I have a mate who also did geomatic engineering like myself. Engineer Henry knows him very well. He's now a mining manager in Canada, and that is how we have to develop ourselves to be able to be as versatile as possible so that we can survive in this career world now, because the competition is great. So you should be. We are not saying we say jack of all trades. Those times they will say that jack of trade, you are not a master of none. This time around, be a master of all. Be a master of all, and make sure that when the opportunity presents itself, you have the skill to take up that challenge. Thank you, Engineer Henry and the team. Thank you very much. Hello, sorry, was I audible?
Yes, please.
Madam Moderator, you can now take over. If it's not
Yes,
online,
yes.
somebody can take over.
So yeah, at this section, we will open up for question and answers. So, since my colleague is not online, I would like to take over. I am Abdullah. So, we will move on our next on the program answer. That is the question and answer section. So, we take the first question. We take the first question from Abdul. The question is directed to Engineer Akrasi. Abdul Mumin would like to know the role of income in mining industry. And the second question is, how do you make sure the expenses of the income is reduced as a geomatic engineer?
Okay. Thank you for the question. And the MINCOM, that's the Mining Commission, or the Minerals Commission. They refers to the regulatory body that's overseeing the mining sector in Ghana. And their role involves ensuring compliance with mining laws, regulating mining activities, issuing licenses, monitoring environmental and social impact, and a whole lot, royalty, taxes, and a whole lot. So as I did through my presentation, you will notice that there are some compliances. We are moving as a geomatic engineer. You need to help the company to move from compliance to proactive management. Do you get it? Being in the TSF, you do the monitoring of the TSF to check the levels. Level, we need to be at this level. We give them daily data, daily update, whether being it a sump, whether being it a whole rule standard, whether being it a community department, you help them with regards to farm compensation, you help them with regards to with pit monitoring, pit walls and everything, because anything that regulation will at the end of the day be fined by the company. So you need to contribute to that to reduce the certain things. We have voluntary and involuntary. There are certain things it can happen. What no matter who you are, it can easily happen. Whether being it a war failure, whether the wars, the it to prevent the walls from collapsing, which will result in income coming in. Thank you. Please, are you okay?
Thank you very much.
Thank you so much, sir. So please, the second question is that This one, it's in two folds. The first part is what causes overbreak and then underbreak. And then the follow-up question is, how do you correct excavation limits after detecting overbreak or an underbreak? Thank you.
So, as the last speaker rightly said, all these ones are being influenced by the blasting activities, and also with our drillers being when they are scaling the walls and everything. So, with the blasting, I told you from the beginning, the moment we move from the outside, you are getting in the transition and the fresh, and the moment you enter into the transitions and the fresh materials, it's left with drill and blast. So we blast, so your blasting can affect your overbreak, your blasting can affect your underbreak. So you give them the correct design. Anytime you make sure to give them the correct design. And with both of this one, there's a margin. Do you get it? You create error, you create room for error or uncertainties whereby it shouldn't exceed. So the moment it is over bricks and it is at the end of the day, it exceed your limit, the contractor will be accountable to that, or they are going to pay. You are going to even deduct the over bricks from their end money. And the moment it is under brick, meaning they couldn't reach the target, so you go and remark the place for them again to continue or they should maybe try and fix it. So it comes as a geomatic engineer, you need to do this daily as they are mining, as they are developing. You need to check your as built. I told you as we are mining, then we are building. So we need to get what is on the ground on the computer against your design, because we mine according to design and we design to mine. So you check from your as built and your design to see that are they mining to the design. So the overbreaks and underbreaks come in if they are mining to the design or they are not mining to the design, and the influence is from the drilling and the blasting.
Okay, sir. Thank you so much. Please, the next question
Mr. Moderator, there are big people to onboard, so in case if they want to add some to it. Dr. Henry and the last speaker, I didn't get the name well. Mr. Andy, we asked you allowed them to.
Okay, sir. Thank you so much for the correction. So please, Engineer Henry and then Mr. Edward, please, we want to hear something from you people since you have a lot of experience in this, to add up to the questions that have been asked so that we can add more questions to it.
I think there was a second question to what a questioner posed, which is how do you reduce the main cost to the geomatic engineer? I couldn't quite understand it, but if I understand correctly, it may be saying that the fees to get certified as a main surveyor might be too high. I don't know the situation in Ghana. I know ship bosses are certified. You have to go through a test. Some geological functions are all specified. And maybe he's talking about the survey aspect as well. But these things are negotiation. The main come up with their fees. And if the industry thinks it's too high, the Chamber of Mines or the relevant bodies will have to negotiate. So there's nothing much that the mining companies can do. They have to channel these things through the Chamber of Mines. That's all I can add.
Okay, thank you so much. Please, Mr. Edward, please, do you have anything to add up for us? Okay, so I think we will move on to the next question, since I think Mr. Edward is a bit off. Yeah. So someone also is asking, how do you verify that support installations match design specifications? Thank you.
Okay, thank you, Mr. Moderator. So as I mentioned earlier, with underground support system, if that's what you want to know, the geotech team will give you the point where they want the cable boat and everything to be installed. So we don't install it anywhere. The geotech team will give you. So within an odd drive, we need to make sure that there's a support system. And within any drive, there's a support system. But with cable boats, whether being it a service drive, whether being it a stopper, whether being it an odd drive, whether being it an escape access or anywhere. So the geotech team will give you the coordinate or the locations where they want that place to be fixed, and you go and mark it for them. So the moment the jumbo operator get there, or the person who is going to fix the cable boat get there, he will see your mark. And we have spray paint we use for any work we do underground. So the moment anytime they see a plus of maybe yellow paint, they know it's a cable boat. Anytime they see a plus of maybe red paint, it's telling them different thing. Anytime they see a spray of white tape, white spray, is telling them different thing. So you can easily go there and check that where you mark it for them, is it the same place they have drilled to install the cable boat? So after installing the cable boat, they will tension the cable boat to make sure that is it fixed, or is the place okay, or is it going to be loose. So these are some of the, we do visual, this is a visual assessment to check if they are doing the right thing to your design. But the geotech team are responsible for that because they are under the pay stability and everything. Thank you.
Thank you very much, Engineer Akrasi. So we'll take the third question. It says, I would like to inquire whether MINCOM is responsible for ensuring that mining companies comply with the ISO 45001 standard, or if there's another authority that oversees this compliance.
Okay, thank you. So when it comes to the mining industry, for what I know, it's not under one uh let's say body only for Mincom. We have EPA people to be on board, the Environmental Protection Agency. They are responsible of the environment, and the Mincom people are responsible to make sure that you are mining responsibly per their laws. Do you get it? So mining, as I said earlier, mining is a partial business. It's not a joke. So any rules, any law governed for you to mine safely, responsibly, you are working with people, we put them in practice. So Mincom don't even need to be here to tell you to make sure that you are mining regards using the standard. You yourself, at the end of the day, will put that one into practice. For example, at Newmont, there was a Newmont manager way back then. He was driving his private vehicle, not company vehicle, his private vehicle at home. And one guy took a picture of him driving the vehicle. The man was not in seatbelt. And the Mincom company took it up and took him out of sight because you are preaching of safety. So you need to make sure that even in your house, you take safety home. So with regards to the standard we use for mining, either EPA, the Mincom, or any body governing the mining industry, is not a joke. And you witness to that if you come for any attachment, or maybe in the future if you are working in the mining industry. So all standards are being practiced here. Thank you.
Yeah, hello. My phone is almost off to what she just explained. For MENCOM is a regulatory body, but ISO is a standard body. So when you achieve the standard by 5001 and you establish it in your company, you use it for a period of 3 years. But it has given you the standard that the company is recognized worldwide. Regulatory body that works with you hand in hand. So the end of your project. I don't know if you get me. As MENCOM is a regulatory body, but ISO is a standard body. So when you achieve the standard by 5001 and you establish it in your company, you use it for a period of 3 years. But it has given you the standard that the company is recognized worldwide. Regulatory body that works with you hand in hand. So the end of your project. I don't know if you get me. Akrasi said, we have a lot of regulatory bodies, but ISO is not a regulatory body, but it's a standard body. So it gives the company standard to be recognized in the arts worldwide. So that's the difference. Aside that, we have EPA. When it comes to manufacturing, so we have factory and manufacturing. We call them FOSA. For them, they are responsible for safety in manufacturing.
Mr. Moderator, you can go ahead.
Thank you so much. I think we've exhausted enough almost all the questions that were being thrown at us. Since this presentation was such an insightful one, we've learned a lot from it. We've understood a lot of things. Though we've not been, most of us or some of us have not been to the mining companies or have not experienced either surface or underground mining. Through this presentation, I can say we have a vivid picture of what a geomatic engineer is required to be doing when you get to the industry. And I know this will go a long way for us in our career. Yeah. So thank you so much for the questions, and thank you to bosses for the answers. God bless you. At this point, we are going to take our chairperson's closing remarks, and we are going to take that.
Okay, thank you very much, moderator. Please, can I be heard?
Yes, please.
Can I proceed?
Yes, please.
Okay,
Please, you can proceed.
Thank you once again. As we bring this workshop to an end, thank you. So as I said, as we are bringing this workshop to an end, I want to thank from surface to subsurface application of geomatics in mine planning, environmental monitoring, and rehabilitation. It has been a great pleasure for you to participate in this workshop. I want to thank Mr. Wisdom, Gyapong Akrasi, for his great presentation on the topic, which has helped us to know and appreciate the role of geomatics in the execution of the various stages of mining. I also want to thank Engineer Dr. Henry for also sharing his experience, vast experience with us from the time he was in Cameroon School of Mines through to his whole professional experience and professional growth he has shared with us on the application of geomatics in his work. I also want to thank Mr. Ami here for also sharing his professional experience with us. I hope the insights shared have been valuable and will continue to be meaningful to our professional growth. Workshop together. I want to thank every workshop. And also grateful for the active engagement. Forward to seeing you at our next workshop. Have a good day. Thank you. Madam Moderator, can you?
Yes, please.
Okay.
Thank you so much. Thank you. God bless you for your time, your energy, and everything that everyone has put together for this presentation. We are going to the last thing on our presentation for today. We are going to take the vote of thanks from Mr. John Kingsford. So, Mr. John, please do us the honor of giving us the vote of thanks. Thank you.
On behalf of us, students, the Geomatic Department, we would like to give our sincere thanks to the Almighty God for a successful webinar. Without him, it wouldn't have been success. And our appreciation also goes to Engineer Henry Entry for his support and for his experience that he has shared with us. That is very educative to us, and we hope you are going to learn very much, and it's going to help us improve in our career. And we also thank Engineer Mr. Wisdom Akrasi Gyapong about land surveying, GIS. But today we learned new things, that Geomatic is not all about the tapes, not the theodolite, not the leveling instruments. So we thank you for that. That's a presentation. That was very educative and insightful. We also thank our chairperson, Mr. Dr. Clement Kwesu, for your support, and also Mr. Edwin Amehe for your experience you shared with us. And thank you everyone for your time and your resources you spent. We hope that all of us have learned something.
Thank you so much, Mr. John. That was a wonderful vote of thanks. So as Mr. John said, we are so grateful to each and everyone that made this workshop a success. And God bless us all and then replace everything we lost in the process. To those of us that are here, I hope we learned a lot, and we are going back to our WhatsApp platform so that we will give the takeaway from it. And if there are further questions, they can be dropped in the WhatsApp platform so that they can be further addressed. Thank you so much for your time. God bless you and have a wonderful evening.
Thank you, Madam Moderator. And please, to those of us who want the recorded session of this workshop, it will be posted on the AusIMM Tarkwa Students Chapter YouTube channel, so you can check it out. Thank you all. Have a wonderful evening.